Alright, welcome back. This is Portland Math Tutor. This is Laiche. Today we are going to be working on the math section of the SAT practice test number 3. Let's dive in. So the first section that we're going to be working on is the no calculator section, section 3. Okay. Number 1, a painter will paint in walls with the same size and shape in a building using a specific brand of paint. The painter's fee can be calculated by the expression NKLH, where N is the number of walls, K is the constant with units of dollars per square foot, L is the length of each wall in feet, and H is the height of each wall in feet. If the customer asks the painter to use a more expensive brand of paint, which of the factors in the expression would change? Well, that's pretty straightforward. All of the factors in the expression in number of walls, K is a cost in dollars, right? L is a length of a wall, dimensions, and H is a height of the wall, also dimensions. So the only value or only dollar units in this are going to be from K. Alright, number 2. If 3r equals 18, what is the value of 6r plus 3? Okay, well, we need to figure out what r is. So 3r equals 18, divide both sides by 3, r is 6. Well, if r is 6, then 6, we just substitute that into the second expression. We get 36 plus 3, 39. Alright, which of the following is equal to a to the 2/3 for all values of a? Alright, well, it's important to know that when you have a fractional exponent, the numerator is an exponent and the denominator is a root. So x to the a over b could be the b root of x to the a, or it could be the b root of x all raised to the a. One of these two. And if we look over here, we've got 3 is the denominator, so that's going to be the root. That's going to eliminate these two. And we have 2 as the numerator, so that 2 is going to be the exponent, d. Okay, number 4. The number of states that joined the United States between 1776 and 1849 is twice the number of states that joined between, okay, so I'm going to highlight that, twice the number of states that joined between 1850 and 1900. If 30 states joined the United States between 1776 and 1849, and X states joined between 1850 and 1900, which of the following equations must be true? Well, we know that in the earlier period they had 30. And we know that that was twice what joined in the latter period. And the latter period is x. So 30 equals 2. 30 equals 2x. Okay. Number 5. If 5 on x equals 15 on x plus 20, what is the value of x on 5? Okay, well, we have a proportion here, and we're going to need to figure out the value of x. Okay, so a couple ways to look at this. I could just look at this and see that, oh, I know that 5 times 3 equals 15, so I know that x times 3 must equal x plus 20. Okay, that's one way to solve it. It might not be totally clear what this scale factor is, so you may have to solve this with another method. The easiest method that I use to solve proportions is to cross multiply. So if I multiply on a diagonal here and here, we'll get 5x plus 100, and we'll get 15 times x. Okay, I'm going to subtract 5x from both sides and get 100 equals 10x, therefore x must be 10. Okay, and 10 on 5 is 10 divided by 5. That's going to be 2. Okay, number 6. If xy is a solution to the system of equations above, what is the value of x minus y? Okay, so we have to solve the system. I'm going to solve this with elimination. I'm going to multiply the first equation by 3, and I'll multiply the second equation by 2. That's going to give me common coefficients on the x terms. So I'm going to end up with 6x minus 9y equals 3 times negative 14. It's going to be 3 times 10 is 30, 3 times 4 is 12. Add those together, we get 42. I know the answer is going to be negative, so it's going to be negative 42. On the bottom, we've got 6x, negative 2 times 2 is negative 4y, and 2 times negative 6 is negative 12. Okay, if I subtract these two equations, my x terms will cancel out. Negative 9y minus negative 4, so that's going to be negative 5y. Then I've got negative 42 minus negative 12, so that's adding 12. I'm going to have negative 30. Okay, so divide both sides by negative 5, I'm going to get y equals 6. Okay, now to figure out what x is, I'm just going to plug that back into one of my equations. So I'm going to pick the first one. 2x minus 3 times 6 equals negative 14. Okay, so that's 2x minus 18 equals negative 14. So 2x, I'm going to add 18 to both sides. I'm going to get positive 4. X must equal 2. Okay, and we're looking for x minus y, so that's going to be 2 minus 6, negative 4. All right, number 7. The function f is defined by a polynomial. Some values of x and f of x are shown in the table above. Which of the following must be a factor of x? Okay, so if we have, let's say we've got let's keep it simple. Let's say we've got a parabola, and we have x-intercepts here and here at maybe 1 and negative 2. Well, then we know that factors, the two factors that we're going to have are x plus 2 and x minus 1, because we want a, and then we're going to have some a value, right? That's going to equal y, because we know that when x equals 1, right, y equals 0. So that's 1 has to make one of the factors equal 0 in our function. That gives us a 0 y value, and the same for -2. -2, when we put it in, we have to have an output of 0 for y, so one of our factors has to be equal to 0, and that's why we get this x plus 2. Okay, so where is our output equal to 0? Our output is equal to 0 right here. That's where we have an x-intercept. And x equals 4. Well, what factor would make 0 when you input a 4? Well, x minus 4 would be that factor. Okay. Number 8. The line y equals kx plus 4, where k is a constant, is graphed in the xy plane. If the line contains the point CD, where c is not equal to 0 and d is not equal to 0, what is the slope of the line in terms of c and d? Okay, so let's get a pen. All right. Well, we know we have a point CD. That's given. We also have the equation of the line y equals kx plus 4. Well, we know that this term right here, the b term in our y equals mx plus b form of the equation, is going to be our y-intercept. When we know the y-intercept, x equals 0 at the y-intercept, so we know we have a point 0, 4. Okay, so then we can use the slope formula. We're just going to do y minus y on top of y1 minus y2 on x1 minus x2. So let's pick a y1. Let's pick this as our first point. Okay, so that's going to be D. And this will be our second point. So it'll be D minus 4 over, well, C minus 0. Okay, well, that's just going to be C in the denominator, so D minus 4 on C would be our slope. Alright, number 9. In the system of equations above, k is a constant and x and y are variables. For what value of k will the system of equations have no solutions? Okay, very well. Well, we know we can have no solutions, we can have one solution, or we can have an infinite number of solutions. Okay, those are the three possibilities. Now, for an equation that has no solutions, we have no solutions. We know that the slope of the lines, has to be equal. Okay, slope of the lines has to be equal, and the y-intercepts have to be different. Okay, so if we just put these two equations in slope-intercept form, we should be able to solve this problem. So I'm going to start with the first one. Okay, I'm going to subtract kx from both sides, kx plus 4, and divide by -3. I'm going to get k on 3 x plus 4/3. Okay, so that's the slope of the first equation. And let's go ahead and do the second one. We're going to get 4x minus 5y equals 7. I'm going to subtract 4x from both sides, -4x plus 7, and divide by 5, or -5. I'm going to get 4/5 x minus 7/5. So as we can see, yes, we have different y-intercepts, and we know that the slopes have to be equal. So therefore, I know that 4/5 must equal k on 3. Okay, well, I'm going to get a little bit of room actually. I'll do it over here. 4/5 equals k on 3. If I cross multiply, I'm going to get 12 equals 5k, and divide by 5, I get 12/5 equals k. So that's going to be A for my answer. All right, number 10. In the xy plane, the parabola with equation y equals x minus 11 squared intersects the line with equation y equals 20 at 2 points, A and B. What is the length of A, B? Okay, well, I'm just going to sketch this graph real quick. We know that this transformation, the only thing that's happening is it's shifting our parent function x squared to the right 11 units. Okay, very well. So it's going to look something like that. It's maybe a terrible drawing. And then we're going to have our y equals 25 is just going to be a line, a horizontal line. And we want to know the length between these 2 points. Okay, so we need to find the coordinates of those 2 points. All right, so we want to know where these two equations are equal to one another. So I am going to set them as equal. So I've got 25 is going to equal negative 11, x minus 11 squared. All right, now in certain situations you might want to expand this and gather like terms and then maybe use the quadratic formula to solve this. However, I'm seeing that if I can just take the square root of both sides. All right, so the square root of 25, that's just 5 plus minus equals x minus 11. Okay, so we're going to have two equations where it's negative 5 equals x minus 11 and 5 equals x minus 11. Okay, solving for x, I'm just going to add 11 to both sides. Get 6 equals x. Add 11 to both sides over here. Get 16 equals x. Okay, now what is the value? Well, I guess that's all we need, really. We don't need to plug this back in to find the y values because we're just looking for the distance, the linear distance, the horizontal distance between 6 and 16, and that is going to be 10. Okay, 11. In the figure above, lines KL and M intersect at a point. X plus y and u plus w equals u plus w. Which of the following must be true? Okay. Well, I'm just gonna highlight some of my my vertical angles here. X and y. Well, I know that x is equal to t. Yeah, and I know that y is equal to u. Okay. All right. So let's see what's going on here. We got x plus y equals u plus w. Well, let's see. I know that y equals u. So if I subtract, I can subtract y, and I can subtract u, because those are equal value, right, from both sides. And I'll get x equals w. Okay, x equals w as well. All right, well, I'm going to go in here. I'm going to highlight that. So x equals w. Well, w and z are vertical angles. So though x must equal t, w, and z. All right, so now let's go down to our possible solutions. Does x equal z? Yeah, x equals z. Does y equal w? Not as far as I can tell, no. Y does not equal w. Does z equal t? Yeah, z equals t. So it's going to be answer 1 and 3. Okay, number 12. In the quadratic equation above, a is a non-zero constant. The graph of the equation in the xy plane is a parabola with a vertex at CD. Which of the following is equal to D? Alright, so we want to figure out what our vertex is. Okay. Alright, so one way to find the vertex is to, well, we know the vertex is going to fall. We know the vertex is going to fall halfway between the two intercepts. So the x value at the vertex is going to be the average of the y-intercepts. We have our equation in factored form, so we know what the x-intercepts are. The x-intercepts are going to be -4 and +2. Well, the average of those, add them up, -2 divided by 2, you're going to get -1 would be the average. Okay, so if the vertex x value is going to be at -1, well then c equals -1. Okay, so now to figure out what d equals, we're just going to put this into our equation. So y equals a times -1 minus 2 and -1 plus 4. So that's going to be -1 minus 1 is 2 is -3. -1 plus 4 is +3. So that's going to be -9a. Answer A. Okay, moving right along. Number 13. The equation blah blah over ax minus 2 equals, got this expression here, is true for all values of x not equal to 2 on a, where a is a constant. What is the value of a? Okay, well, if we divide polynomials and we have a remainder, that remainder is going to need to be divided by the divisor. Right? So the quotient, the whole quotient is going to be minus 8x minus 3, and then this minus 53 is a remainder of that division. Now, to start to get at the heart of this, we can multiply both sides by the divisor, ax minus 2. If we multiply the left side by ax minus 2, we're just going to get our numerator. Okay, if we multiply the right side by ax minus 2, well, we're going to have to multiply the first piece by that, and we're going to have this remainder, this minus 53. That denominator is going to get eliminated. So we're going to have negative 8x minus 3 times, let's get a little bit more room, times ax minus 2, and then minus 53. Okay. So now if we're able to equate the coefficients, I think we'll be able to figure out what our a value is. So equating the coefficients just means that we're going to expand this side, and then we're going to see what are the coefficient, what's the coefficient on the x squared term, what's the coefficient on the x term, and what is the constant. So to start this out, I'm going to have negative 8a x squared, those two multiplied, and then I'll have positive 16x. Then I'm going to have negative 3 times ax, so minus 3ax. And then I'm going to have plus 6, and then minus 53. Okay, I'm going to combine like terms, but what I'm also going to do, since I need to have an x term, is I'm going to group these together and factor out that x, so that I have a coefficient on the x, on my x, and just one x. And then I'm going to combine these two as well. So I've got negative 8ax squared, and I'm going to have plus 16 minus 3a times x. Now if I distribute this x, I'll get positive 16x and negative 3ax. So now what I have is a coefficient on my x term, which is exactly what I'm looking for. And then here I've got minus 47. Okay, so let's see. Well, now we know that, oops, did not want that, I want the highlighter. 24 must equal this, and 25 must equal this. Okay, well, I think it's probably easiest to look at this, the first coefficient. We have negative 8a equals 24. Divide by negative 8, we get a equals negative 3. B is our answer. All right. 14. What are the solutions to 3x squared plus 12x plus 6 equals 0? Okay, so the solutions all look like we're going to be using the quadratic formula. That's fine. Before we start doing that, I'm just going to simplify this a little bit. I'm going to factor out a 3. I'm always looking for common factors when I'm trying to work with quadratics. Oops. That's going to be 4x plus 2 equals 0. Alright, now I can use the quadratic formula. A equals 1, B equals 4, and C equals 2. I know that x equals negative b, so that's going to be negative 4 plus minus square root b squared, which is going to be 16, minus 4 times a times c. Well, that's going to be 1 times 2, which is 2, all over 2a, which is going to be 2. Okay, so I'm going to simplify inside the square root. I'm going to get 16 minus 8, well, it's just 8 over 2. Alright, well, that's not one of my solutions. I'm going to need to simplify this square root. And I can pull out a perfect square. Alright, so that's going to be negative 4 plus minus the square root of 4 times the square root of 2 over 2. Okay, well, that's going to be negative 4 plus minus 4 root 2 over 2. Okay, and we are almost done here. X equals, I'm going to divide every term by 2, So that's going to be negative 2 plus minus 2 root 2. Squeeze that in there just barely. So that's going to be our A, will be our solution. Okay, 15. We've got an equation that shows the temperature F in Fahrenheit relates to temperature C in Celsius. Based on the equation, which of the following must be true? Okay, so the first one is the temperature. The temperature increase of 1 degree Fahrenheit is equal to a temperature increase of 5/9 degrees Celsius. Well, we should recognize that this is a linear. This is a linear function. Now this is going to be 5 times 32. That's going to be what, 160 over 9. That's not so important, but we should see that this is in the slope equals, or y equals mx plus b format, and we see that our rate of change is 5/9. So as F increases 1 degree, Celsius, or Fahrenheit, increases by 1 degree, Celsius is going to increase by 5/9. So yes, A, or 1 is a solution. Okay. All right, a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. Well, to figure that out, all we have to do is just write this guy in to find the inverse. So we're just going to, all we need to do is solve for C. Or sorry, solve for F. Okay, so I'm going to add 160 over 9 to both sides. Okay, and then I need to multiply by the reciprocal to get rid of this 5/9. So I'm going to multiply everything by 9/5. So this will be multiplied by 9/5. This will be multiplied by 9/5. That's going to be 9/5 C plus, well, I'm not even very concerned with what this is. I know the 9s are going to cancel out, so I'll get 160 over 5 equals F. Okay, so this says that 1 degree increase in Celsius is going to be 9/5 increase of a degree in Fahrenheit. Well, 9/5, 1/5 is 0.2, so 9/5 is 1.8. So yes, that part 2 would also be true. And next it says a temperature increase of 5/9 degree Fahrenheit is equivalent to a temperature increase of 1 degree Celsius. No. If we increase Fahrenheit by 5/9, well, Celsius is going to increase by 25/81. Yeah, so that's not a solution. So 1 and 2 only. 1 and 2 only. Okay, 16. X cubed times x squared minus 5 equals negative 4x. If x is greater than 0, what is one possible solution to the equation above? Okay, I'm going to expand this out and see what we get. If I distribute that x cubed, I'm going to get x to the 5th minus 5x cubed. I'm going to add 4x to both sides, and I'll set it equal to 0. Okay, well now I can I'm always looking for a common factor. I can factor out an x. I'll get x to the 4th minus 5x squared plus 4 equals 0. Okay, well, this, I'm recognizing this is a multiple of 2, and this is a multiple of 2 here. So what I could do is just say if u equals x squared, then I can do a substitution. I'll get x times u squared minus 5u plus 4 equals 0. Now factoring is going to be much easier. Just factors. A is 1. I'm looking for two numbers that multiply to 4 and add to negative 5. Well, that's going to be u minus 1, u minus 4. Okay. Well, I know that u is x squared, so I'm going to get x squared minus 1 and x squared minus 4 equals 0. Okay. And I know that these are both difference of squares, so we're going to have x minus 1, x plus 1, x minus 2, x plus 2 equals 0. So we're going to have 5 solutions, and we know that x is greater than 0, so we can start to rule out some of these solutions. This would be x equals 0, this would be x equals negative 1, and this would be x equals negative 2. So we have these two factors. X would be equal to 1, or x would be equal to 2. So 1 or 2 are possible solutions. Alright, 17. 7/9 x minus 4/9 x equals 1/4 plus 5/12. What is the value of x? Alright. So on the left side, I'm going to combine like terms. I'm going to get 3/9 x, okay, equals, and on the right side I'm going to get common denominators. So I'm going to multiply the first term by 3 over 3. I'll get 3/12 plus 5/12. Okay. I'm going to multiply both sides by, I'm going to do 2 steps at a time here. I'm going to multiply both sides by the reciprocal to get rid of that 3/9 coefficient. I'm going to do the same thing over here, 9/3. Okay. These guys are going to cancel out. I'm just going to have x. And on the right side, I'm going to have, well, this is going to be inside of here. This is going to be 8/9, or sorry, 8/12. Okay, 8/12. 8/12 can simplify to divide by 4. We'll have 2/3 times 9/3. Okay, divide that by 3. Divide that by 3. Oops, divide that by 3. Get 1. So we'll see that x equals 6/3 or 2. Alright, 18. We've got a drawing here. Two isosceles triangles are shown above. If 80 or 180 minus z equals 2y and y equals 75, what is the value of x? Okay. So let's see. Alright, I'm going to draw a larger triangle here. We know this is z, and we know this is x. Okay. Well, we can say that inside of here, this angle right here must be, well, that must be 180 minus x. If these are isosceles triangles, then this as well would be 180 minus x. Okay. we know that so we know that 2 of these and z must equal 180. So 2 of these guys right here, well, that's going to be 360 minus 2x plus z. Well, we know that must equal 180. Okay. We also know that 180 minus z equals 2y. Well, I'm recognizing that over here that I could get a 180 minus z on the right side pretty easily. So I'll see that 360, I'm going to subtract z from both sides, equals 180 minus z. Okay, well, 180 minus z equals 2y. Okay, perfect. So 360 minus 2x equals 2y. Okay, well, we know that y equals 75, so I'm just going to take this and plug in 75 for y. I'll get 360 minus 2x equals, well, what's 2 times 75? 2 times 75 is 150. Subtract 360 from both sides. 150 minus 360, 360 minus 150, see, that's going to be 210, so that's going to be negative 210, and divide both sides by negative 2, and we're going to get a positive 105 for x. Oops. Okay, 19. At a lunch stand, each hamburger has 50 more calories than each order of fries. If 2 hamburgers and 3 orders of fries have a total of 1,700 calories, how many calories does a hamburger have? Okay, so each hamburger has 50 more calories. Each hamburger has 50 more calories than an order of fries. So fries plus 50. And we know that 2 orders of hamburgers plus 3 orders of fries has a total of 1,700 calories. And we want to figure out how many calories a hamburger has. Well, since we want to figure out how many calories a hamburger has, I'm going to eliminate the fries. So I'm going to solve this equation for f, which is going to get me h minus 50 equals f, and then substitute this f value into my second equation here. Okay, so I'm going to get 2h plus 3 times h minus 50 equals 1,700. Okay, so that's going to be 2h plus 3h, distribute that 3, minus 150 equals 1,700. I'm going to combine like terms and get 5h. I'm going to add 150 to both sides, 1,850. Now we can just divide by 5. Well, 5 goes into 18 3 times with a remainder of 3. 5 goes into 35 7 times with no remainder, and then it goes into 0 times. So a hamburger has 370 calories. Okay. In triangle ABC, the measure of B is 90 degrees. Alright, well, I'm just going to sketch this out real quick. B is 90 degrees. BC is 16, and AC is 20. So that's A, and that's C. Well, that means that AC is 20, and BC is 16. And triangle DEF is similar. Okay, DEF, so that's going to be D. E is going to be corresponding to B because it's in the middle, and C corresponds to F. Vertices DE and F correspond to A, B, and C, respectively. And each side of triangle DEF is a third of the length of the corresponding side in triangle ABC. What is the value of sine of F? Well, we know these are, if we know these are similar, then we know that this angle F is equal to this angle C. Okay, so then really all we need to do is find sine of C. Sine of C is just going to be opposite over hypotenuse. Okay, so that's going to be opposite over hypotenuse. So it's going to be something over 20. And to figure out this opposite side, we need to use the Pythagorean theorem. The Pythagorean theorem just says that the two sides, the sum of the sides squared, I'm going to use x for the unknown side length, is going to be equal to the hypotenuse squared. The square of 16, gee, that's going to be 6, 3, 9, 6, 1. We're going to get 6, 256. So 256 plus x squared equals, well, 20 squared. 2 squared is 4 with 2 zeros. That's going to be 400. So we got x squared equals 400 minus 256. Let's squeeze this in here. 256. That's going to be a 9, a 10. It's 4, 4, 1. So x squared equals 144. Square root of 144 is 12. So this side length is 12. So the opposite of C is going to be 12. Okay. Now we can reduce that by a factor of 4, and we'll get that the sine of C is 3/5. Well, since we know the sine of C is going to be equal to the sine of F, we don't have to worry about this second triangle at all. Okay, so this is a classic problem where they give you extra information, and you might go down a rabbit hole of trying to figure out the side lengths of this second triangle, when all we need to do was find the sine of C, 3/5. Okay, section 4. This is the calculator section. All right, number 1. We've got the graph above shows Mary Lynn's distance from her campsite during a 3-hour hike. She stopped for 30 minutes during her hike to have lunch. Based on the graph, which of the following is closest to the time she finished lunch and continued her hike? Okay, so it says that during a 3-hour hike, she stopped for a 30-minute lunch during her hike. 30-minute lunch during her hike. Okay, so the distance should not have been changing during that time because she wasn't moving. So we're looking for a horizontal line segment that is 30 minutes long, and that looks like that segment right there. And so it says, based on the graph, which of the following is closest to the time she finished lunch and continued her hike? Well, it looks like she finished right here, I don't know, 150, 140, I guess. 140 would be the closest. So C is our answer. Okay. 2. The table above shows the distribution of age and gender for 25 people who entered a contest. If the contest winner will be selected at random, what is the probability that the winner will be either a female under age 40 or a male age 40 or older? Okay, so the winner is going to be selected at random, and we know that our total population is the total sample is 25. Okay, and we're looking for female under 40. So female under 40, that would be here, or male 40 or older. Well, that would be right here. Okay, so that's going to be 10. It's going to be 10 out of the total 25. Okay, 3. The graph below shows the total number of music album sales in millions each year from 1997 through 2009. Based on the graph, which of the following best describes the general trend in music album sales from 1997 through 2009? So it looks like we could say that they kind of went up a little bit, right? And then 3 years after, around 2000, it started going down, kind of plateaued for a little bit, and then sales have been declining for quite some time now. So A says the sales generally increased each year since 1997. Well, no, clearly not, right? They're declining. B, sales generally decreased each year since 1997. I would not say that either, because around this first piece, sales were increasing. So I'm not gonna select that one either. C, sales increased until 2000, then generally decreased after that, and that sort of looks like what we were describing from the graph. And D, sales generally remain steady. Steady would be a horizontal line, so that's not going to be it. Our answer is going to be C. Okay, let's see. 4. The table above shows some values of the linear function f. Which of the following defines f? Okay, well, they said it's a linear function, therefore the rate of change is going to be constant, or the slope is going to be constant. And we can see that slope is just going to be change in your output over change in your input. I'm going to pick these first two, and I'm going to say, okay, so f of 1 minus f of 2, those are the output values, over 1 minus 2, this should equal the slope. Well, f of 1 is negative 2, and f of 2 is 1, over 1 minus 2, that's negative 1, and then negative 2 minus 1 is negative 3. Negative 3 over negative 1 equals the slope, so the slope is positive 3. So we can eliminate 1, 2, 3 of these. The only one with a slope of 3 is C. Okay. At Lincoln High School, approximately 7% of the enrolled juniors and 5% of the enrolled seniors were inducted into the National Honor Society last year. if there were 562 juniors and 602 seniors enrolled at Lincoln High School last year, which of the following is closest to the number of juniors and seniors at Lincoln School last year who were inducted into the National Honor Society? Okay, so we know that there were 7% of juniors, and there were 562 juniors. We know that there were 5% of seniors, and we know there were 602 seniors. Okay, so what we're going to have to do is we're just going to add these up. I'm going to do these color coded. So we're going to do 562 juniors, and we're going to multiply that times 0.07, 7%, plus we had 602 seniors, and we're going to multiply that by 0.05%. So that should equal our number of students inducted into the National Honor Society. I am going to pull out my calculator. Let's see. So we're going to do 562 times 0.7 or 0.07. So this is going to get us 39.34, and I'm going to do 602 times 0.05. That's 30.1, and now I'm just going to add those up. Well, it's going to be 69.44, and we want to know which value is closest. Well, clearly B, 69, is closest. Okay. 6. Which of the following is the sum of the two polynomials shown above? Okay, well, we're just adding two polynomials together. That means we're combining like terms. We want to think about how many x squareds do we have. Well, we have 3x squareds on top and 5 on bottom, and that's going to be a total of 8x squared. Well, we have negative 5x on top, negative 2 on bottom. That means we're going to have a total of negative 7x. Okay, and then we're going to add the constants. 2 plus negative 6 is negative 4. So 8x squared minus 7x minus 4. A will be our answer. Okay. If 3/5 W equals 4/3, what is the value of W? Okay. For this, we need to either divide by 3/5, which you should know is the same as multiplying by 5/3, the multiplicative inverse. What's going to happen is these guys are going to cancel out on the left, and we'll be left with W. That undoes that 3/5 multiplication. And on the right, we're just going to multiply straight across, 29ths. D. 8. The average number of students per classroom at Central High School from 2000 to 2010 can be modeled by the equation y equals 0.56x plus 27.2, where x represents the number of years since 2000 and y represents the average number of students per classroom. Which of the following best describes the meaning of the number 0.56 in the equation? Well, this has been coming up a lot. You guys should have this burnt into your brain. Y equals mx plus b. Y is the slope. B is the y-intercept. And for this function, what we're modeling with this function is the average number of students per classroom, right? So X is years and Y is students in the classroom. So it looks like at 0 years past 2000, which would be at 2000, the number of students in the classroom was 27.2. And then every year since then, as X increases by 1, the average population in the classroom has been increasing by a rate of the slope, and the slope is 0.56. That's the rate of increase in students per class per year. So A, the total number of students at the school, no. The average number of students per classroom in 2000, no. The estimated increase in the average number of students per classroom each year, yes. C would be our answer. And D, the estimated difference between the average number of students per classroom, no, that's not it either. Okay, C is your answer. Okay, 9. Nate walks 25 meters in 13.7 seconds. If he walks at the same rate, which of the following is closest to the distance he will walk in 4 minutes? So he walked, this is a proportion, he's going to walk 25 meters in 13.7 seconds, and we want to know how many meters he walks in 4 minutes. Well, 4 minutes is going to be 240 seconds. Okay, so to get this, you could cross multiply and all that hubbub, but in this case, I think it would be much easier just to, if we want to isolate this x, we just need to multiply both sides by 240. Okay, so then we're going to get 240 times 25 divided by 13.7 equals x. Okay, we can just plug that straight into the calculator. 240 times 25 equals 6,000 divided by 13.7 divided by 13.7. So 437.96. Okay, and it says what's closest? Well, that's going to be 450 meters. Okay, so this one was kind of, let's see if we can, oh boy. All right. The chart above shows approximations of the acceleration due to gravity in meters per second squared for the 8 planets in our solar system. The weight of an object on a given planet can be found by using the formula weight equals mass times gravity, where W is the weight of the object and newtons, and m is the mass of the object measured in kilograms, and g is the acceleration due to gravity on the planet measured in meters per second squared. Okay, 10. What is the weight in newtons of an object on Mercury with a mass of 90 kilograms? Okay, so we know that we have our formula here. Okay, so all we need to do is plug and chug. We want to find the weight. Well, that's going to equal the mass, which is 90 kilograms, and times the acceleration due to gravity, and we're looking for gravity on Mercury. Acceleration due to gravity on Mercury is 3.6, so 3.6. Okay, so we can just plug that into the calculator. 90 times 3.6, that's going to give me 324. D. Okay, 11. An object on Earth has a weight of 150 newtons. On which planet would the same object have an approximate weight of 170 newtons? Okay, well, I think I'm going to want to figure out the mass of the object. So let's see this out. So we got the weight is 150 newtons. That's going to equal the mass times gravity on Earth. Gravity on Earth is 9.8 meters per second squared, so times 9.8. I'm going to divide both sides by 9.8. 150 divided by 9.8. 150 divided by 9.8. It's going to give me a mass of 15.3 kilograms. Okay. So then we're trying to figure out on which planet will this mass have a weight of 170 newtons. So one way to do this would be to plug this mass of 15.3 into the equation with each acceleration due to gravity. That's going to take a long time. So why don't we solve for the acceleration due to gravity based on a weight of 170 newtons and a mass of 15.3 times g. Okay, so we'll solve this and we can just pick from the list. So 170 divided by 15.3, that's going to be 11.1 equals acceleration due to gravity. And we can see that that is Saturn, so our answer is B. Okay. If the function f has 5 distinct zeros, which of the following could represent the complete graph of f in the xy plane? All right, well, if it has 5 distinct zeros, that means that it crosses the x-axis in 5 distinct places. Okay, so let's count for A. 1, 2, 3, 4. That can't be our, that cannot be our solution. What about the next one? 1, 2, 3, 4. Again, that cannot be our solution. Looking for 5 distinct zeros. Okay. Let's go to C. 1, 2, 3, 4, 5, 6. Crosses the graph in 6 places. Okay, that is also not what we're looking for. So finally, let's look at D. 1, 2, 3, 4, 5. Yes, D will be our solution. Okay. The equation above gives the height h in feet of a ball t seconds after it's thrown straight up with an initial speed of v feet per second from a height of k feet. Which of the following gives v in terms of h, t, and k? Okay, so this is a type of problem that I've seen on all versions of the practice test that I've looked at, and really all we're doing is solving for v. So we don't really, all the details about this situation, throwing the ball and feet per second, all that, don't really matter. We're just solving a literal equation. So I'm going to start with my equation over here. I'm just going to isolate the v. Okay, so I'm going to add 16t squared to both sides and subtract k. So I'm going to get h plus 16t squared minus k equals vt. Okay, I'm going to divide both sides by t, get h plus 16t squared minus k over t equals v. Okay, well that does not look like our equations, our solutions. So there's no squared term in any of the solutions, so I think we're going to need to get rid of that, separate this into 2 fractions to isolate the, to cancel out one of those t's. Okay, so what I'm going to do is I'm I'm going to write this as h minus k plus 16t squared over t equals v. Okay. Let's see if I can move this. Oh, no. Okay. Now I can separate that into two fractions. It can be h minus k over t plus 16t squared over t equals v. Okay. Well, the first fraction can't simplify, but the second fraction I can cancel out a t. So it's going to be plus 16t. So we have h minus k over t plus 16t. And that is going to be answer number D. Or not number D, letter D. Okay. 14. The cost of using a telephone in a hotel meeting room is 20 cents per minute. Which of the following equations represents the total cost C in dollars for h hours of phone use? That's nice of them. They underlined hours to really point that out. So if it's 20 cents per minute, how much is it per hour? Well, there's 60 minutes in an hour, so we're going to need to do 60 times 0.2, or times 20 cents. Okay, well, that's going to be 120, and we have one decimal place, so it's going to be $12 per hour. Okay, so we're looking for which of the following equations represent total cost C in dollars for phone use. Well, C is going to be the hours times 12. Oh, but they a little bit simpler than that. 12, we didn't actually have to multiply. Kind of got ahead of myself there. So it's going to be 20 cents times 60 times number of hours, A, in that direction. Okay. 15. In order to determine if treatment X is successful in improving eyesight, a research study was conducted. From a large population of people with poor eyesight, 300 participants were selected at random. Okay, large population of people with poor eyesight selected at random. People were selected at random. Half of the participants were randomly assigned to receive treatment X. Okay, so half were assigned to receive treatment X, and the other half did not receive treatment X. Okay. The resulting data showed that participants who received treatment X, had significantly improved eyesight as compared to those who did not receive treatment X. Based on the design and results of the study, which of the following is an appropriate conclusion? A. Treatment X is likely to improve the eyesight of people who have poor eyesight. I'm kind of leaning, that sounds like a good answer. Let's see what the other options are. B. Treatment X improves eyesight better than all other available treatments. Well, that is not, we can't possibly make that conclusion because no other treatments were included in the study. C. Treatment X will improve the eyesight of anyone who takes it. Also, can't make that conclusion because the people in the study were people with poor eyesight. And D. Treatment X will cause a substantial improvement in eyesight. That's one of those blanket statements that isn't really founded based on a study. This is very declarative. It is likely to improve the eyesight for people who have poor eyesight, but it's not guaranteed, right? So we're going to say A. Okay, 16. All right. graphs of the function f and g are shown in the xy plane above. For which of the following values of x does f of x plus g of x equals 0? Okay, well, for f of x plus g of x to equal 0, they must be additive inverses. So it must be that f of x equals x, oops, sorry, additive inverses. So they must have, while one is x, the other must be negative x. Okay, so let's look at the graph and see. So if we start on the right side, as we're coming down, this is way up here. That's f of x. G of x is way down here somewhere. Yeah, that does not look like they will add up to 0. Here you have 2 and negative. That doesn't add to 0. Here you have negative 1 and negative 1. Well, that would add to negative 2. If we have, oh, right here, so when x is negative 2, f of x is positive 2, and g of x is positive 2, and f of x is negative 2. Those would be additive inverses, and they would add up to 0. So at x equals negative 2, the sum of the functions is 0. Okay, let's see. All right. The quantity of a product supplied and the quantity of a product demanded is in an economic market are functions of the price of the product. The functions above are the estimated supply and demand functions for a certain product. The function S of P gives the quantity of the product supplied to the market when the price is P dollars, and the function D of P gives the quantity of the product demanded by the market when the price is P dollars. Okay, and as you can see, they're both linear equations, and I'm just gonna do a little sketch here. And it looks like they're going to the supply, as the price of the product goes up, guess what? Supply goes up. And as the price of the product goes down, as the price of the product goes up, the demand goes down. All right? And eventually, at a certain point, a certain P value, a certain price, the demand curve will equal the supply curve. All right, 17. How will the quantity of the product supplied to the market change if the price of the product is increased? The quantity of the product, if the price is increased, the quantity of the product supplied to the market, well, that's going to increase, right? And we want to know, that's going to be your supply function. It's going to be the supply function. And if the increased by $10, well, P times a half, oops, P times a half, well, 10 times a half is 5. Well, then the quantity of product supplied will increase by 5. So the quantity supplied will increase by 5 units. B. Okay. All right. Next problem, 18. So here we've got, at what price will the quantity of the product supplied to the market equal the quantity of the product demanded to the market? Well, we're just going to, again, we want to find this equilibrium point, this point where they meet. To do that, we're going to set these equations equal to each other. So we've got our supply function. We're going to set that equal to our demand function. Okay, and I'm going to add P to both sides. So I'm going to get 3 halves P, and I'm going to subtract 40 from both sides, equals 180. All right, well again, if we want to get rid of that coefficient, we need to multiply by the reciprocal. That would be 2/3. These guys are going to cancel out. We're just going to be left with P. And we can reduce this over here, I believe. We can divide the bottom by 3, we'll get 1. Divide the top by 3, we'll get 60. 60 times 2 is 120. So 120 is the price where demand equals supply. And we will continue number 19 on the next slide. Okay. Number 19. Graphene, which is used in the manufacture of integrated circuits, is so thin that a sheet weighing 1 ounce can cover up to 7 football fields. If a football field has an area of approximately 1 1/3 acres, how many acres can 48 ounces of graphene cover? Okay, so well, we know that we can cover 7 football fields, and a football field is this many acres, so it's going to be 7 times that many acres, and I'm going to write that as an improper fraction. That's going to be 4/3. So that's how many acres a single ounce of graphene can cover. Okay, well that's going to be 28/3 of an acre, and we want to know 48 ounces. That's just 1 ounce, so it's going to be 28/3 times 48. Well, I can divide the top and the bottom by 3. I'll get 16 on top, so now I've got 28 times 16. That's going to be 12, 16, 8, and 2, 8, 4. So 448 448 acres. So that would be closest to 450. Okay. All right, 20. Michael swam 2,000 yards on each of 18 days. The scatter plot above shows his swim time for and corresponding heart rate after each swim. The line of best fit for the data is also shown. For the swim that took 34 minutes, Michael's actual heart rate was about how many heartbeats per minute less than the rate predicted by the line of best fit. So we need to find the data point that corresponds to the 34-minute swim time. So if we come up here, 34 is right here, and the point corresponding to 34 minutes is right there, and that is one little tick mark below 150. So we got to figure out what these tick marks are worth. Well, there are 1, 2, 3, 4, 5 sections in between 140 and 150, so each section must be worth 2. So the actual heart rate is going to be about 148. The prediction by the line of best fit looks like it crosses right at the 150. So right at 150 for the predicted. Okay, so and how much more or how much less than the predicted is the actual? Well, that'd be 2. That would be 2. Okay, number 21. Of the following 4 types of savings account plans, which option would yield exponential growth of the money in the account? All right. A. Each successive year, 2% of the initial savings in the is added to the value of the account. Oh, well, 2% of the initial savings. Oops. Of the initial savings. That would be the same every year, right? 2% of the initial deposit is just going to be the same amount every year. So that increase that's going to increase at a linear pace. B. Each successive year, 1.5% of the initial savings and $100 is added to the value of the account. Okay, well, again, we're basing this off of the initial savings, even though you're adding $100, right? So it'll be the same. It'll be linear, but it'll be a greater increase. Okay. C. Each successive year, 1% of the current value is added to the value of the account. Okay, well, that makes more sense to me. That would be each year you have an initial deposit, and each year you're increasing faster and faster and faster and faster and faster, right? Because each year you're taking 1% of the current value. Well, the current value is increasing, so 1% is going to be more each successive year. So the rate of change will increase. So the answer is going to be C. We'll just read D. Each successive year, $100 is added to the value of the account. All right, that will also be a linear increase. Okay. The sum of 3 numbers is 855. One of the numbers, x, is 50% more than the sum of the other 2 numbers. What's the value of x? Okay, well, looks like x plus y plus z is going to equal 855. And we know that x is 50% more. X is 50% more, well, than the sum of the other 2. Well, that's going to be 1.5 times y plus z. Okay. What's the value of x? Okay. So what we need to do here is we can see that we have a y plus z here, a y plus z here. We want to isolate x, so we don't want to eliminate x. If we substitute in and eliminate x, well, it's going to be extra steps because we're going to have to solve for y. We want to get rid of two variables in one foul swoop, and to do that, all I have to do is divide by 1.5. That equals y plus z. So now I can substitute that in for that expression up there. So I've got x plus x over 1.5 equals 855. Now if I just multiply everything by 1.5, I'll eliminate my denominator. I'll get let's get better. Okay. 1.5 x, well, that'd be plus x, canceled the denominator, and then go to my calculator here. 855 times 1.5 equals 1282.5. Okay, so that's going to be 2.5x equals 1282.5. I'm going to divide both sides by 2.5, and I'm going to get 513. Okay, so then x must be equal to 513. Okay, 23. The angles shown above are acute, and sine of A equals cosine of B. If A equals 4k minus 22 and B equals 6k minus 13, find the value of k. Alright, well, I think it's going to be important to, let's look at an example here. If we have a right triangle here, and we'll call this A, and we'll call this B, we'll call this C. Well, sine of A, this would be lowercase a, lowercase b, and lowercase c. Sine of angle A is going to be opposite over hypotenuse. It's going to be A over C. Cosine of B is going to be adjacent over hypotenuse. That's going to be A over C. Okay. Well, we also know that, yeah, so if two angles are what's called complementary, yeah, these are complementary because they add up to 90 degrees, then the sine of one will be equal to the cosine of the other. And likewise, if the sine of one is equal to the cosine of the other, you know that they must be complementary. So we know that angle A, in this case, angle A plus angle B in degrees must equal 90. All right, well, it gives us some expressions. Oops, 90. Gives us some expressions for these. A is 4k minus 22. And B is 6k minus 13. Well, we know that's going to add up to 90 degrees. Combine like terms, that's going to be 10k minus 35 equals 90. All right. And 10k must equal, add 35, it's going to be 125. So k must equal, divided by 10, it's going to be 12.5. So C is our answer. Okay. 24. Mr. Cole has a beaker containing n millimeters of solution to distribute to the students in his chemistry class. If he gives each student 3 millimeters of solution, 3 millimeters of solution to each student, he will have 5 millimeters left. 5 millimeters left. In order to give each student 4 millimeters of solution, he will need an additional 21 millimeters. How many students are in the class? Well, he's got a leftover. He's got a leftover of 3. Sorry, he has a leftover of 5. Of 5 milliliters, right? And if he adds an additional 21 millimeters, then he can give all of his students an extra milliliter of solution. Well, that means that he would be distributing 26 additional milliliters among his students, and if each one got an extra milliliter, then there must be 26 students. Okay, 25. A grain silo is built from 2 right circular cones and a right circular cylinder with internal measurements represented by the figure above. if the following, which is the closest to the volume of the grain silo in cubic feet? Okay, well, we've got two cones and a cylinder. So we need to figure out the volume for the cones and for the cylinder. The volume for a cone is going to be 1/3 the base area, which is pi r squared times the height. Okay, that's going to be for the cone. I'm going to do a little triangle for the cone. The volume of the cylinder is going to be, well, the base pi r squared times the height. Okay, so we know we have two cones, therefore we're going to have to find we're going to do 2 times 2 times 1/3 pi. The radius of the cones is 5, so it's going to be 5 squared times the height of the cone, which is 5, plus we're going to need the volume of the cylinder, which is going to be pi r squared, which is 5 squared times the height, which is 10. Okay, so what we're going to have here is, I'm going to distribute that 2/3. That's really going to be 5 to the 3rd, which is 125 pi, plus it's going to be 25 times 10. That's 250 pi. And then we're going to have 2/3 of 125. Now let's do that on my calculator. So 125 divided by 3 times 2. It's going to be 83.3 pi plus 250 pi. Okay, add 250 to that, and we're going to get 333.3 pi. Okay, all right, so we're going to need to multiply times pi, and we get 1047 point, I'm going to round to 10th, 0.2. Okay, and 0.2. Okay, yes, that works. D would be our solution. Okay, 26. In the xy plane, the line determined by the points 2k and k32 passes through the origin. Which of the following could be a value of k? Alright, so if we know that a line passes through the origin, then we know one point. Oops, we know one of the points must be 0, 0. Okay, and since it's a line, we know that the slope is going to be constant. So the slope between 0, 0 and 2k must be the same as the slope between 0, 0 and k32. Okay, so we'll just set this up. I'm going to do the slope of between these 2 points. That'll be the change in y, right? K minus 0 over 2 minus 0. Well, I know that has to be equal to the slope between these 2 points. And do the change in y, that'll be 32 minus 0 over k minus 0. Alright, and to solve this, we're going to cross multiply. I'll get k squared equals 64. Square root, I get k equals positive negative 8. So we have 8. A rectangle was altered by increasing its length by 10% and decreasing its width by p%. If these alterations decrease the area of the rectangle by 12%, what's the value of p? Oh boy. Okay. Let's see. So we know that the relationship between these measurements is going to be the area equals length times width. All right. And we know that we increase the length by 10%. So that means we're going to multiply the length by 1.1. Yeah, 1.1 times the length. And we know we decrease the width by p%. Well, if we decreased by p%, that's really going to be 100 minus p. All right, 100 minus p. That gives you the percent. But then we need to convert it into a decimal, so we need to divide by 100. So this is what we're going to multiply times w, because we start with 100%, decrease p%, and that gives us the percent, but to write it as a decimal, divide by 100. Okay, so then we're going to have 100 minus p over 100 times w. That's a decrease. And we know that the alterations decrease the area of the rectangle by 12%. Well, if we decreased by 12%, then the new area will be 88% of what it used to be. So we're going to need to multiply the area by 0.88. It's 88% of what it was before. Okay, and now let's see what we can do here. I think I'd like to get that area out of there. I'd like to write this in terms of L and W, because it looks like I could, if I do that, then I can divide both sides by L and W, and then I would have an equation with just P. So I'm going to go ahead and rewrite this. 88 times LW, which is the area, and we got 1.1 times length times 100 minus P over 100 times W. Okay, so I'm going to divide both sides by L and W, and what I'm left with is just 0.88 equals 1.1 times 100 minus P over 100. Okay, perfect. That cleaned up nice and neatly. Okay, so I'm going to divide both sides by 1.1, and that's going to be 0.88 divided by 1.1. It's 0.8. 0.8 equals 100 minus P over 100. Multiply both sides by 100. I'm going to get 80 equals 100 minus P, and then I'm going to subtract 100 from both sides. 20, negative 20 equals negative P. Multiply both sides by negative 1. 20 equals P. So C will be our answer. Okay, 28. In planning maintenance for a city's infrastructure, a civil engineer estimates that starting from the present, the population of the city will decrease by 10% every 20 years. If the present population of a city is 50,000, which of the following expressions represents the engineer's estimate of the population of the city after city T years from now? Okay, so we're going to be y equals a b to the x. Okay, Now, this is our exponential function. A is our starting value. That's the 50,000. That's the 50,000 that the current population is. And then b is the common ratio. That's what we're multiplying by each time. So we're multiplying by the same amount each time here. Now, what are we multiplying by every 20 years? Well, we're decreasing by 10% every 20 years. Well, decreasing by 20%, or sorry, 10% every 20 years. That means that after 20 years, we're going to have 90% of what we had before. Okay, well, that means that we can, I don't want to do that. Let's just do one line through it. We can eliminate that because that's multiplying by 0.1, right? That would be after 20 years, we had 10% left, or decreased by 90%. Okay, all right, so now if we're looking at our exponent here, we want that to equal 1, right? We want one cycle of decrease after 20 years. So we want x, in this case, the x here, to equal 1 when the number of years is 20. Okay, well, for the number of years to equal 20, or sorry, number of years to equal, or x to equal 1 when the number of years equals 20, you're going to have to divide 20 by 20, right? The number of years is going to have to be divided by the number of years it takes for one cycle of this decrease to happen. So we're going to have this exponent needs to be number of years divided by 20. Okay, so we're going to have D as our solution. Okay, 29. The incomplete table, The incomplete table above summarizes the number of left-handed students and right-handed students by gender for 8th grade students at Kiesel Middle School. There are 5 times as many right-handed female as there are female students as there are left-handed female students. Okay. Well, gee, I think it's going to make sense to write that in. So, and read that again. There are 5 times as many right-handed as there are left-handed female students. So, if I write left-handed as just F, then there are 5 times F right-handed as left-handed. Okay. If there's a total of 18 left-handed students and 122 right-handed students at the school, which of the following is closest to the probability that a right-handed student selected at random is female? Okay. All right, let's figure this out. Oh, I think I skipped something here. 5 times. There are 9 times, yes, so there are 9 times as many right-handed male. 9 times as many right-handed male as left-handed male students. Okay, that makes sense. All right, so now we've got a system, F plus M. Well, that must equal 18. The number of left-handed students is 18. And 5F plus 9M, that must equal 122. Okay, so it's a system of equations. I'm going to solve for M, because I want to eliminate my M, my male students, because the question here is about female students. So I'm going to have M equals 18 minus F, and I'm going to substitute that back in for my male in the second equation. So I've got 5F plus 9 times 18 minus F equals 122. And I'm going to distribute and combine like terms. 9 times 18, that's going to be 90 plus 72, 162, minus 9F equals 122. I'm going to combine like terms on the left. I'm going to get negative 4F, and I'm going to subtract 162 from both sides. 162, 162. So that's going to be negative 40. Divide by negative 4, I'm going to get 10. So there's 10 female left-handed students. There's 10, let's see, 10 female left-handed students. Okay. And the question is, down here it says, if there's a total of 18 left-handed students and 122 right-handed students, which of the following is closest to the probability that a right-handed student selected at random is female? Okay, well, if there's 10 female left-handed, there must be 50 right-handed. So that's going to be 50 out of 122. Okay, and we'll plug that into the calculator to get a decimal solution. 50 divided by 122, that's going to be 0.441, round to the nearest hundredth. Yeah, and that'd be A. Okay, number 30. In the equations above, B and C are constants. If B is C minus 1/2, which of the following is true? Okay, so B equals C minus 1/2. All right. So what I'm going to do is I'm going to plug that into my first equation. So I'm going to get 3x plus C minus 1/2 equals 5x minus 7. Okay. Now if I solve for C, I can replace that into my second equation. Okay, so I'm going to solve for C. I'm going to subtract 3x from both sides. I'll get 1 minus 1/2 equals 2x minus 7. Add 1/2 to both sides, 2x, and I'm going to just convert this into a fraction. That's negative 14 halves plus 1 is negative 13 halves. Negative 13 halves. Okay, so that's C. Well, now I can substitute that into my second equation. So I'll get 3y plus 2x minus 13 halves equals 5y minus 7. Okay, and looks like I want to solve for x because all of these solutions are x is. That means x equals something. Okay, so I'm going to solve for x. Subtract 3y from both sides. I'm going to get 2y minus 7. And then I'm going to add 13 halves to both sides. So I'll get 2x equals 2y. Well, this is negative 14 halves. That's 7. Negative 14 halves plus 13 halves. That's going to be negative 1/2. Okay, divide both sides by 2, I get x equals y, and divide 1/2 by 2, I get negative 1/4. Okay, so x is y minus 1/4. All right, 31. Tickets for a school talent show cost $2 for students and $3 for adults. If Chris spends at least $11, but no more than 14 on X student tickets and 1 adult ticket, what is the possible value of X? Okay, so we know that he bought 1 adult ticket. Adult ticket is 3. Is 3. And to that, we're going to add some multiple of x, but each x is a student ticket, right? So those cost $2, and we want that to be greater than 11, but we also want it to be less than 14. Okay, so I'm going to subtract 3 through, so minus 3, minus 3, minus 3. I get 11 is greater than 2x, which is greater than 8. Okay, divide everything by 2, and I will get 5.5 is greater than the number of tickets, student tickets, which is greater than 4. So at least, so this needs to be like so. So we could have 4, x could be 4 or 5. Okay, all right, moving on. We have 32. Ages of the first 12 United States presidents at the beginning of their terms in office. Okay. The table above lists the ages of the first 12 United States presidents when they began their terms in office. According to the table, what is the mean age in years of the presidents at the beginning of their terms? Round to the nearest 10th. Okay, so we're just going to be adding up all their ages and dividing by 12. I'm going to do that on my calculator here. So I've got 57 plus 62 plus 58 plus 58 plus 59 plus 58 plus 62 plus 55 plus 68 plus 51 plus 50 plus 65 equals, so the sum of their ages equals 703. So now if we want the mean, well, that's going to be 703 divided by 12. So that's going to be approximately 58.58. And it wants us to round to the nearest 10th, so we're going to say 58.6. Okay. All right, 33. If the expression above is written in the form ax squared plus bx plus c, standard form, where a, b, and c are constants, what is the value of b? Okay, well, b would be on the coefficient on the x term, or the linear term. So we're really looking for here is 5x plus, well, whatever this equals, whatever this is going to equal when we multiply it by -2. Okay, and that is going to be -2 times that, so that's 5x. That's equals, equals 5x plus -2 times -x. It's going to be 4x. So that's going to be 9x. So B equals 9. Okay. 55. In a circle with center O, central angle AOB is a measure of 5 pi on 4 radians. The area of the sector formed by the central angle is what fraction of the area of the circle? Okay, so for this, we have a circle. We have 5 pi on 4, so that's going to be something like this, that angle right there, 5 pi on 4. And we want to know what fraction of the whole circle is this. Well, the area of the sector to the area of the whole circle is going to be proportional to the central angle, or sorry, this angle out of the whole. Okay, so we're looking for the whole measure is going to be 2 pi. The central angle that we're talking about is 5 pi on 4, and we can simplify this as 5 pi on 4 times the reciprocal of 2 pi. Okay, so pi's are going to cancel out, and we'll get 5/8. So 5/8 is the fraction of the whole area. Okay, 35. An online store receives customer satisfaction ratings between 0 and 100 inclusive. In the first 10 ratings the store received, the average, or the arithmetic mean, of the ratings is 75. Okay, what is the least value the store can receive for the 11th rating and still be able to have an average of at least 85 for the first 20 ratings? Okay, so this is a kind of a confusing wording here. All right, well, let's start from the beginning here. We know that over 10 ratings they had an average of 75. Well, the average 75 is equal to the sum of the first 10 divided by 10. Okay, so then the sum of the first 10 must be 700. Okay. All right, so we know that's the total of the ratings from the first 10 customers. That's the first 10. So I'm going to do sub 10. There you go. Sum of 10. All right, and we know that they want to have a 85 average. They want to have an 85 average for 20. Okay, well, that's going to be the sum of 20 divided by 20. 85, go to my calculator, 85 times 20, that's 1,700. So 1,700 has to be the sum of the 20. Okay. So they've already had 10 reviews, and they've got the 11th, 12th, 13, 14, 15, 16, 17, 18, 19, and 20 to go. All right, so they're saying what's the least value they can receive on the 11th. So on the 11th review, all right, now if they get a really bad score on that, they've still got a ways to pick it back up, right? They still have 1, 2, 3, 4, 5, 6, 7, 8, 9 more reviews to raise the score, raise their
total average for the first 20. Well, in an ideal situation, they get 100 on each of these reviews, each of these 9 reviews from 12 to 20. Well, that would be, what did I say? 1, 2, 3, 4, 5, 6, 7, 9. So that'd be 900. Okay, so assuming they get 900 on 12 through 20, what's the least they can get on 11? Well, we want 750 plus the 11th. I'm just going to write, oops, plus the 11th, plus 900 for the subsequent 9. We want that to be greater than or equal to 1700. Okay. Well, subtract 750, subtract 1650 from both sides. We'll get that the 11th has to be greater than or equal to 50. Okay, and they want to know the least. They want to know the least value. The least value the store can receive on the 11th rating. Well, the least value would be 50. Okay. 36. In the xy plane, if a point with coordinates a, b lies in the solution set of the system of inequalities above, what is the maximum possible value of b? Okay, so let's do a sketch here. Okay. Of course, this is not to scale, but that's okay. So I'm going to do the first one in red. It's a linear, and we have an intercept of 3,000, and it's going down at a rate of 15. Okay, so, and it's a solid line because y is less than or equal to. So y is less than or equal to. All right, for our next one, we'll do in blue. Try that again, do in blue. Y is less than 5x. Well, 5x less than or equal to 5x. 5x is just going to be some kind of line that goes up like this, and we want to know where x is less than. So like that. And we're looking for what is the maximum possible value of b? B, which is going to be our y value at our solution. Well, the maximum y value is going to be right here at the intersection of those two lines. Okay, so if I just set those two lines as equal, 5x is equal to negative 15x plus 3,000, and solve for x, that'll give me my x value. I can plug it back in and find my y value, or in this case my b, my a. This is a, and this is b. Okay, I'm going to add 15x to both sides. I get 20x equals 3,000, and divide by 20. I'm going to get, well, drop a 0, I get 150. So x is 150. When x is 150, I'm going to use the second equation. Y is going to be equal to 5 times x. So that's going to be 750. Okay. Okay, last two problems here. If shoppers enter a store at an average rate of R shoppers per minute and each stays in the store for an average time of T minutes, the average number of shoppers in the store N at any one time is given by the formula N equals R times T. This relationship is known as Little's Law. The owner of the Good Deals store estimates that during business hours an average of 3 shoppers per minute enter the store and that each of them stays an average of 15 minutes. The store owner uses Little's Law to estimate that there are 45 shoppers in the store at any time. Okay. 37. Little's Law can be applied to any part of the store, such as a particular department or the checkout lines. The store owner determines that during business hours approximately 84 shoppers per hour make a purchase, and each of these shoppers spends an average of 5 minutes in the checkout line. At any time during the business hours, about how many shoppers on average are waiting in the checkout line to make a purchase at the Good Deals store? Okay, so we know that there are 84 shoppers per hour making a purchase. That means that there's going to be 84 shoppers are going to be coming to the checkout line per hour, right? So that means that we need to, our formula above, let's see, T is the average number of shoppers in the store, N is, so R shoppers per minute. Okay, so if we're in 84 per hour, we need to convert that into minutes. So 84 per hour, well, there are 60 minutes in an hour, so we divide that by 60. My calculator, 84 divided by 60. So we see that 1.4 people are entering the checkout line per minute on average. Okay, so that's going to be our R value. So this is R. Okay. All right. Now, so 84 shoppers per hour make a purchase, and each of these shoppers spends an average of 5 minutes in the checkout line. Okay, so if we come back to our equation up here, we see that the average time of T minutes that the customer is in the store or in the department or in the checkout line, in this case, is T. So in our case, we're going to have T is going to be 5 minutes. Okay. All right. So we want to figure out at any time during business hours about how many shoppers on average are waiting in the checkout line to make a purchase. Well, that's going to be N. N is the number of the average number of shoppers in the store, or in this case in the department or in the checkout line. So what are we going to do? We are going to set N equal to R times T, 1.4 times 5, and 1.4 times 5 is, on my calculator, this is going to be 7. So N, in this case, equals 7. Okay. Okay, 38. The owner of the Good Deals store opens a new store across town. For the new store, the owner estimates that during business hours, an average of 90 shoppers per hour enter the store. Okay. 90 shoppers per hour enter the store. Let's see. Highlight that. 90 shoppers per hour enter the store. And each of them stay for an average of 12 minutes Okay. The average time that they stay is 12 minutes. Average is 12 minutes. The average number of shoppers in the new store is what, at any time, is what percent less than the average number of shoppers in the original store. Okay, so we have to figure out the number of shoppers in the store. Well, the number of shoppers in the store at any one time is going to be R times T. In this case, our R value, we have to convert it to minutes, is 90 divided by 60 minutes. That's going to be 1.5. So our R is 1.5, and our T value is the average number of minutes that they stay in the store. That's going to be 12. So we're going to be at 18 here. Okay. So in the new store, let's read the question. Answer the question. So the average number of shoppers in the new store at any time is what percent less than the average number of shoppers in the original store at any time? Well, the estimated number of shoppers in the original store at any one time is 45. In the new store, the average is going to be 18. Well, 18 is what percentage? 18 out of 45 is, let's see, 18 out of 45 is 0.4. It's 40% of what the original store was. Well, if it's 40%, and the question is asking what percent less than the average number in the original store, then it's going to be, we're going to have 60% less.